Hello, everyone, and welcome to the show. This is the Geek Nerder podcast, and I'm your host, Keval Yapte. I am joined by Patrick McFadin from DataStax today. And when Patrick is on the show, we talk about Cassandra. So, welcome, Patrick, to the show. I'm really excited to have you. Let's add a little bit of introduction again on the show and what you have been doing in the recent months.
Yeah, and thanks for having me back. I think last time we left it at you're coming back to talk about the other things because we ran out of time. So it was good. And there's plenty to talk about. My name is Patrick McFadin. I've been working on the Apache Cassandra project for about 12 years now. I'm a committer on the project. I also work at DataStax, and that's just my day job. I just do that on the side. No, I run a lot of community activities at DataStax, working with the project. I work with the CNCF. I'm on the CNCF TOC as well. And lately, a lot of machine learning. It's just like anything data I think I get involved in. It's a sickness that I have. But yeah, I think traditional more of an engineer, but I am an engineer. I have a degree in computer engineering, but I do a lot of developer relations because I think this is what you do. I think is so important to our community is, hey, here's this thing, let's discuss it, provide information. I spend a lot of my time doing that.
Amazing. And to our viewers who haven't watched the last episode, it was a masterclass on Cassandra, and we discussed everything basic you should know about Cassandra, how it works, and what is the architecture look like. And I think last time we said that there are new features going to come up in Cassandra 5.0. And once they are released, we are going to talk about them more and explain. So here we are.
Here we
So
are.
yeah, Patrick, let's start with a list of features that you think are really amazing in the new version of Cassandra.
Yeah, so Cassandra 5 is I'm not going to say this lightly. It's one of the biggest changes we've had in Cassandra. It's a it's a huge change for developers, for people who write applications using Cassandra. We've spent the past 10, 12 years stabilizing, building this amazing distributed database. And I think there is just this feeling in the project, and it's what's great is there's so many different companies that participate. We have DataStax, of course, Apple, Bloomberg, Netflix, Instagram, now Roblox. We have so many companies that have engineers that are solving daily problems, and because of that's the way we build it. And it's frustrating for a lot of folks because we don't go on a marketing release schedule
Mm.
and say, hey, we're having a conference, let's do a release. Our release schedule is based on, hey, we have a certain set of problems that we want to solve. And usually it has something to do with our actual, like how we use Cassandra. And then we build those features, we propose them, we build them. And some of them take a while. But 5.0 is a culmination of a lot of things on our wish list, I think. The first one, of course, you mentioned Accord, but it's ACID transactions with Cassandra, which has never been an option. We've had lightweight transactions, which are single partition, but this is multi-partition transactions. We'll talk way more about that in a minute. Another one is an enhanced indexing scheme called storage attached indexing, which is a pretty bad, leave it to a project to not name things very well. But storage attached indexing is a completely different way of doing indexing across large data sets. And it will give us the ability to do some really amazing things. There's some stuff that's happening on the Stargate project, which is a API gateway for Cassandra that will be taking advantage of this. And it's basically like a full JSON API that will take advantage of all the indexing that happens underneath. There are other things sprouting out from that. Vector search is one of those, of course, outside of the indexing. Those are some of the biggest features. There's another feature that is really difficult to discuss because it doesn't look like it impacts you, but it's called transactional cluster metadata. Again, we're really bad at naming things, but essentially what it is doing is it's creating a whole new paradigm in how the cluster is managed. And it's opening the door for a lot of really interesting things like having version schema and being able to do instantaneous upgrades, like being able to scale immediately. So if you need twice as much capacity, you can do it immediately. And it's done deterministically. If you notice, all of these problems seems to be like, hey, like at DataStax, we run a lot of Cassandra with our Astra product. So we deal with this all the time. And these are problems that come up. So those are probably the big rocks, and we'll probably pick some out as we go along too.
Absolutely. That sounds like an amazing feature list in the new version. And in the interest of time, I think we can discuss the asset properties and
Mm-hmm.
the vector search because that sounds really interesting. Let's start with the asset properties thing, right? So, asset properties are really important and they come from the world of relational database where you just get it for free and you don't have to think about them. But in the Cassandra world, who is using Cassandra, why do they need asset properties? What are the use cases when they are using Cassandra and they also need asset properties?
Yeah, the classic asset transaction example is moving money, right?
Yeah.
The transaction is moving money from Alice to Bob. And that's a hard one, right? Because if you're moving money from one account to another, you want to
Mhm.
make sure that that happened. You can't do half of it.
Yeah.
Banks are not going to survive with that. It's a good example of what we're trying to accomplish. It's a terrible example of what actually happens in the real world. Banks don't use ACID transactions for this. Everything's done on a ledger. If you look at the use cases on Planet Cassandra, there are a ton of them out there that are banks, and they're not using ACID transactions right now. That's a different world. But if you look at like that type of problem, that could be done something like e-commerce, where you need to make sure that if you only have 10 things left in stock, that you only sell 10 things and not 11. Or if you're doing document locking, you want to have an exclusive transaction. Exclusivity is really the key. The way I describe asset transactions from a developer standpoint is you want to look like you're the only developer working on the database. If you have a multi-user system, I used to be an Oracle DBA, that when we had hundreds of users, and boy, that was a lot,
Yeah.
you wanted each user to feel like they were the only ones interacting with the database. And so there was all these controls around that. And ACID transactions were a big part of that, right? And so that exclusivity gives developers the safety, the feeling of safety. And I think that's why ACID transactions are still really high on people's list, because it just lets us be lazy. We don't
Yeah.
have to think about consistency of our data when the database just takes care of it and deals with it for us. So
Yeah.
we're putting all that functionality on the database.
Yeah. That makes sense. And it looks like it will simplify a lot of application logic that we have to figure out as a developer. If I have to implement asset properties, if my database doesn't support it, I have to do something at the application level if I have to guarantee something of that sort. And if my database is doing all the heavy lifting, then it's great. Okay, good to know that Cassandra is finally supporting asset properties at the massive scale that Cassandra works at in a distributed manner. Why was it not enabled before? Like, what was stopping Cassandra to implement asset transactions?
Yeah, that's a great question. And it's because, and it gets it a little more into the history of consensus. And I think that's important because this is the kind of show that you run here. We're going to go deep. Let's do it. And
Yeah.
it comes down to how distributed systems work and how we want them to work. If you go all the way back to like really the first consensus protocol, consensus meaning a group of machines agree to something, some change, something. It goes back to Paxos. And that was Leslie Lamport, famous computer scientist who came up with Paxos. And that was in 1989. That was how long ago Paxos was invented. And
Mm,
it was an easy concept to look at, impossible to implement. But if you look at people who actually have to write Paxos code, they lose their mind eventually. But the idea is that if you have, let's say, a group of nodes working like on the same bit of data, that if one of the nodes needs to make a change, it proposes, hey, I want to lock this data, everybody. And then everybody says, oh, okay, go ahead. So there's this consensus. And then that node will be able to work on the data in an exclusive fashion and then release it back and say, okay, I'm done. You can, oh, that makes sense. It's almost like you're working with humans at this point. Hey, can I do this thing? Sure, go ahead. The larger system you get, the more noisy that gets, and it gets into round trips, like how many round trips. The funny thing about Paxos is it's really the root of everything. When he started working towards like how do we build better consensus in Cassandra, Cassandra was the first thing that we built was for scale and for durability. Consensus and those kind of things were more of a secondary thought because we were optimizing for a different problem. We wanted to make sure that your database never went offline,
mm,
that when you put your data in, it was going to be on disk for sure. consistency of that data was left to the operator. And you're right, you had to write a lot of code to get there. So early days of Cassandra was spent way more about building out like the scale and the distributed data. And we put the consensus part to the side. We'll get back to that. But we did implement Paxos in 2013 or 14 with lightweight transactions. But that's only on one partition of data. So it's very limited. That's why it's lightweight, but it's not the full thing.
Makes sense. And thanks for the history. That adds a lot of context to it, like why until now Cassandra did not support like fully fledged asset transactions and why asset is important. With this, let's try to understand why Cassandra is supporting asset transaction based on the Accord consensus protocol, right? How was Accord developed, and like a little bit of history, like what was the motivation? Was it designed specifically for Cassandra, or it can be used for others as well? And why Cassandra or Accord is suitable for Cassandra?
Yeah, that is a bit of a sordid history, and it goes way back. It goes back years. The consensus protocols are always there's always a PhD being written about consensus protocols. If you're a computer science student and you're looking for a thesis, consensus protocols is probably on the top of your list. It's just because it's such an interesting problem and there's different ways to solve it, but there's always a way to optimize it. Like I said, Cassandra, we decided to go with this old, steady, true Paxos because it was so stable. And it was more important for us to have a stable protocol. I remember the discussions at the time. There were other protocol RAFT. See, RAFT is just an easier implementation of Paxos. It uses a leader election instead of building out this consensus through quorum. So it just makes it easier to reason through. So that's what RAFT does. And so we were looking at that, but it creates this leader problem, which if you're working with a leaderless system, adding a leader just is a dumb idea. You're basically taking a wonderfully distributed and durable system and creating a whole new problem. So that was out. Spanner was looked at as well, but Spanner is just sharded Paxos. I'd say just the Google engineers who built Spanner were very smart. But they built it for Google's infrastructure. They knew that they could control the clocks. They used atomic clock to do all of that. And they were able to do some tricks. And so what it does is it's sharded Paxos. So each domain has its own Paxos. So it's just Paxos again, but then they use two-phase commit to shard it into multiple domains. So if you've ever used Spanner and you're like, wow, it takes a long time to do an insert, that's why. And again, for multi-data center, it just slows everything down. And so when we looked at Spanner, we were like, that's going to wreck Cassandra. It just won't fit because it'll slow it way down. And a two-phase commit, again, is another error state that you don't want to have to try to reason through. Again, if you're Google and you run your own infrastructure and you know everything, it works great, but it still has that problem. And then there are other databases like Yogabyte, CockroachDB that all took Spanner, added a little bit to it. Like they changed it around a little bit, added some things to make it a little more performant or whatnot, but they still suffer from that same problem if it's sharded Paxos. So you're basically sharding your database. And as I say often, friends don't let friends shard. Sharding is a great way to stay up at night.
Make enemies.
Yeah, make enemies. But there were some really cool papers after that. The Calvin paper was another one that was really like trying to go after this two-phase commit problem, which makes it really difficult to work with. And FaunaDB uses Calvin and a modified version of Calvin, where they actually control the way that they do. Instead of having to do two-phase commits, they put a lot of the control of the serialized part of the data in each shard. So they're sharded, but they've serialized the shards. So that was a really cool upgrade. It made it a lot faster, but it still required this leader node, which this had to do an elected leader. And again, anytime we talk about elected leader in Cassandra land, we're like, no, just no. Every node needs to stand alone. And there were some other papers after that. And so when the engineers that were working on it, on what should we use, and they were just not satisfied with the current state of the art, which was not aligned with the way Cassandra works. Cassandra needs to be, you need to have the linear scalability. So you add a node, you get more scalability. You need to have shared nothing, which is pretty critical. And then we need to do multi-data center very easily. There should be no failure domains that you get if you decide to leave the same data center. It should be global data, because that's what people use Cassandra for, is this distributed part of the data. So Accord is a derivative. It is actually a derivative still of Paxos, but it eliminates a lot of the issues that other protocols were okay with. Sharding, like doing a two-phase commit. But it's still, to get this right, you still need to have some sort of idea of a leader involved. But the really clever thing about Accord is it creates these small, again, because we know Cassandra, it creates these very small domains of leader elections just inside the replica sets. And those replica sets are replicated as well. So it turns it into these very small bits of leaders that make it very easy for consensus to be made. And it's just a very clever protocol. And when it was proposed like 3 years ago, there was a lot of work, papers, proofs. There were some folks at University of Michigan that got involved. I expect there's going to be lots of papers written about Accord, and I bet you there's going to be a lot of databases that use Accord. But it was built for what Cassandra could do first, and then applying knowledge from the past. It was not completely new. It was just an upgrade on what has been moving along, like the Spanner, the Calvins, all those papers that have happened. This is just the next version out. That's a
Yeah,
long
very
answer. I'm
interesting.
sorry.
No, I think that adds more value because it looks like Paxos is the base of all these consensus protocol, and people have been trying to modify and make it work for their use case. By the way, for our viewers who are not familiar with these leaderless and shared nothing architecture, why Cassandra supports it, please head over to the previous episode because we have talked about that in depth, and I'll link that episode in the description. But yeah, I think it makes sense why Accord is the right choice for Cassandra. And as I understand it, it's basically because it wants to support like leaderless architecture, so no leader. So whatever protocol requires a leader, Cassandra says no. And then the performance, right? The performance should not be impacted, and that's, we are going to understand that a little bit more, like how Accord works. And I'm going to again put you at the hard spot without diagrams and anything to explain how Accord works, but I want to take an example here, right? Since we talk about like bank transactions, let's make it a little bit more interesting, right? Let's say we are playing a game and I am a player and I unlock levels and I get to buy a weapon, right? A weapon
Mm-hmm.
of my choice, but there's only one weapon and I want to buy it, and it's a distributed system and there are failures. So I want to buy this or deduct the coins that I have, like the digital money I have, in a transactional manner. So this is like a transaction, just a better version of a banking transaction, I would say. So let's say I want to deduct money from or coins from my account. I want to add it to the game's account and give me the resource. So these are like three steps happening in this transaction, right? And it's all in a distributed manner. Let's say I build this system on Cassandra, and now that Cassandra supports asset properties, how would that work if there are failures? How is the consensus coming into the picture?
That's a great example, actually. Because yeah, we're yes, I can answer that in a positive way, and that's
Ah,
exactly the type of thing that it is really going to be good for. Again, it goes back to this idea. Hey, you as a developer, are you going to see this exclusively, right? If you're writing the code to go buy this weapon and you want to make sure you only sell one of them, are you going to write a bunch of code to make sure that happened, or are you just going to let the database take care of it? And I think the database is the best choice.
yeah,
Yeah. So there's a few concepts inside of Cassandra transactions that are important. And the first one is this idea of what type of consensus we get, and it's strictly serializable. And what that means is that everyone that in the cluster sees the same change in the same order, and it's exclusive. So the case where there's one thing left in the table, there's just only one, and the counter is at one, and you want to be the only one person to get it and no one else, then the order is what matters. So it should be first come, first serve, right?
yeah,
Okay. The way that transactions work in Cassandra is you create a transaction block. And in the transaction block, the first thing you do is you grab the current state of the system. And when you do that,
Hmm.
you're actually creating a state where you are the only entity, the only process that's accessing these records at this point. So whenever you ask for state, like, all right, give me out of the items table, give me how many of the super vorpal swords are there, and give me a count on that. And that's my example, the super vorpal sword. And then what you would do the next is then you could do, there's a really, probably the best feature about our transactions is there's a conditional block. You could say if, the count of vorpal swords is greater than 1, then take money out of player's account, so minus out 20 coins and then add 20 coins to the bank, and then also add the sword to player's inventory in transaction. Now, in that transaction, I check to see if there is enough swords. Yes, there is. Then I moved the coins from one place to another and gave you the sword exclusively and in order. So if your best friend is right behind you and wants to get the Vorpal sword, if they're a millisecond late, they will not get the sword because you were the first one in line. And that strictly serializable that really makes things work. And you
Mm.
mentioned this is like you wrapped a bank transaction and an e-commerce transaction. I love your example because what happens is the player is happy because, oh, I didn't
Yeah.
get ripped off. I got my sword. But no one else is going to get this weird transaction error because, oh, there's now -1 swords in the inventory.
Yeah.
That whole thing that I just said has never been possible in Cassandra before.
Yeah. And developers need to do it in their code. And of course, when developers do it, there's always a chance of adding a bug or maintaining and modifying that code and writing tests that make sure that it's correct and all that. So it's all complicated. And as a developer, I would love my database to support it out of the box, right? Because I don't want to write and maintain that code. Just to
Yeah.
dissect that code or the transaction block that you mentioned, like you said, begin transaction and you check for the number of weapons left in the items table, and then you deduct money and all that. So this is all happening on like different nodes in a
Mm-hmm.
Cassandra cluster, right? And that's what we are talking about here, right? Different nodes, different states, different times, different failures, all are happening in the distributed system. So how is this transaction block ensuring that? Like, how is Accord coming into the picture here?
Yeah, so whenever your transaction is accepted by the coordinator, that's any node in the system, it parses it, makes sure, first of all, it's valid. The
Hmm.
table names are correct. So once you have
Yeah.
it knows that this is a valid, all of the CQL is valid, then that's when the real activity starts. And so it has to, what it does is in order, it does all the ordering and says, okay, here's all the things that I need to make sure are exclusive. So it will look at the partition keys, and then those go to the replicas or the primary. Because of the way Cassandra works, if you go back and watch the other video, just a reminder, the data that's laid out in Cassandra is built around partition keys. And a partition key has a primary node where that data resides. It's not a master node, that sort of thing. It's just a node that has the data. And then there's replicas, and you can determine how many replicas there are. Most people use 3. You should use 3. Don't use 2, use 3. And that's a great way to keep your data safe. So let's say we have 3 replicas, or there's 3 copies of the data. So it will go to the primary node, go to the primary node, and then say, hey, here's the partition key that this process has exclusive access to, and it puts it into an order queue. And there's some really cool little things that happen here. It's a lot of details, but it's basically, it's knowing where the clocks are in the rest of the replicas and being able to
Hmm.
order things properly, so that instead of having to do a lot of consensus, it says, oh, I know exactly what's happening with this replica data and I can make a determination now. It's giving them, that node, enough power to make a decision so it doesn't have to do round trips. And doing round trips is what costs. That's what Paxos costs a lot. Two-phase
Okay.
commit, round trips. And round trips aren't bad. That's, hey, can I do this? Another node. Yes, you can. Or wait a minute, I'm doing something. All right, I'll wait. Can I do it now? Yes, you can. Those round trips add up. They're safe, But shortcutting that and trying to think about how can we do something in, it's funny, we talk about it being in 1.5 hops because sometimes it's two, sometimes it's one. We always want to try to get it in one. And that's the least. You can't get any less than that. But
Hmm.
by taking those shortcuts in that exclusive, it is like a queue at this point. And if you're at the head of the queue, you are the first one to do it. So your transaction for the Vorpal sword hits that queue at a certain time. And if you're the first transaction on that queue to get done, then you will get the sword. If your friend is the second one in there, by the time they get there, that conditional will fail. And the conditional will come back saying, oh, I'm sorry, there are 0 Vorpal swords. So that transaction will fail. Sorry, it didn't meet the condition. So and it's just a simple order that you think queues, this is something as computer scientists we understand from like day one. This is just a simple queuing mechanism, but we're trying to think about it in terms of node local, replica local, instead of this idea like, oh, let's just broadcast this across the entire cluster. If you have 1,000 node cluster, which a lot of you do, that's going to be a lot of round trips. So keeping it very focused on just that and make sure it's strictly serializable. It's very novel.
Interesting. That makes sense. So the idea behind the reduction of the number of round trips is to have this kind of information where the
Mm-hmm.
replicas are, so that the coordinator can make that decision based on that particular data, and it maintains like a queue of the state of different replicas is what I understand. Interesting. Okay, cool. And then so basically it makes sure that, okay, I get the consensus with one round trip, and for each statement, that is right, like each statement in
Mm-hmm.
the transaction block, it's happening once. So for each resource, each table, I'm going to check it with each. I'm going to get the consensus on the resource, right?
And it's either going to happen or it isn't. And it's really based on
Okay.
that conditional, which is, like I said, that's the best feature around it because it actually makes your code a lot easier, a lot cleaner.
Hmm.
The perfect example, that's why I said your example is perfect because I want to get the last sword. And that's
Yeah.
such a classic problem for computer science is the off by one error. What if you have a Black Friday event and everybody wants this thing? You're going to have thousands and thousands of requests. Ticketmaster in the US is a
Yeah.
great example of when Taylor Swift tickets went online, Ticketmaster got taken offline because
Yeah.
so many people were clicking on the tickets that it shut down their system. It's a real problem.
It's a real problem. Yeah.
Yeah.
Yeah. It's a real problem. And yeah, if my database is doing it, I'm really excited about it. Great. And then, so basically, when I'm running my transaction and then things are failing, so I want to, so I am doing some state changes here, right? Okay,
Mm-hmm.
first statement was, okay, I check the resource or the number of items
Mm-hmm.
left. Okay, there is one sword left. It's okay. Go to the next one. I deduct money. So when I say I deduct money, right, I'm making some state changes. And let's
Mm-hmm.
say the next statement where adding money to the bank's account fails, I have to roll back. How does that happen? You're rolling back the transaction, you're resetting the value. Is it that you handle or you support like multiple versions of the data,
Mm-hmm.
or how is that happening?
First of all, we don't do rollbacks, not yet, at least. That's more of an online transaction or interactive transaction. If you're on a command line, very typical with especially with data warehousing. Since this is like more application based transactions, that condition. Let me unpack that condition that you just gave. Hey, I couldn't move money into my bank account. That actually constitutes a failure of the database because there are no constraints built into a Cassandra database. There's no reason if you say change some data, there's no reason for it to say no if it's valid CQL. There's no constraints on that not working.
Yeah.
But what I would say is if you're worried about that, you can collect that condition in the transaction. Say, not only do I here, let's take your example to the next step. Is I want to get all the items in the item table or the number of items in the item table. Plus, I want to get the user's bank account information or how many coins they have. And then in the conditional, you say, okay, if there's enough items and this person has enough coins, then we can do the transaction. This is a good example of you should understand how it works and use that to your best advantage. If you didn't have that conditional in there and you say, yes, I would like to minus off 20 coins, You have now a potential situation where you could go negative, right? If there was at 0, there would be negative 20 at the end of that. So I would just roll that up into the condition itself. And you can have multiple conditions inside of it with ands and ors. It's really functional. And I think this is what I'm going to be teaching a lot of people how to do, is build out like how to build your prior state, gather the state, and then how to use condition to avoid that situation.
Okay, very interesting. So yeah, there's a little bit of, I would say, learning required on how to pack your transactions
Mm-hmm.
so you get it right. Okay. And
Yeah, it's not the same as like an Oracle transaction where you just do a handful of statements and then you say commit. I'll give you the reason why from a technical standpoint. It opens up a whole new class of problems
yeah.
that we don't want to start tackling, which is rollback segments. So
Mm,
you have to maintain the various states of the database inside the commits. So if you're making interactive changes to the database and there's a commit at the end of it, then something's got to keep track of all of that. And then if you say rollback, it needs to snap it back and or just dump it. And that's a different kind of problem that we're not really ready to solve yet. I think for most people, like the gaming example you gave, you're not going to do a rollback. You're just going to keep moving forward. But when we get into more interactive use cases, we're just not a data warehouse yet. That's the thing. Yeah.
but what happens with the gaming example then? Let's say the you deduct like 20 coins, but you're not
Mm-hmm.
able to give that player the weapon. Is it going to keep trying that until it succeeds, or it's going to try with a separate node? How is that going
Yeah.
to work?
Okay.
Like,
No, I got your meaning. So if there's a node failure, which we
yeah,
should be okay with, right? If you have a
okay,
three replicas looking at one particular set of data, we expect one of those to fail, or two of
mm,
them even. You could have that many.
yeah,
That's how Cassandra is built. Yeah. So that's actually how the one of the features of Accord is that queue that's maintained is maintained across all three replicas. It's just that one, we have this thing called a fast path electorate, which one of them is designated as, okay, I'm the source of truth. And so I get to say yes or no. But if that node goes offline, then the other node will pick it up just as fast. We actually do this with our read replicas. We have this fast failure mode for reads where it's a fun thing to play with. Like you can have a 4 node Cassandra cluster and be reading from it as fast as you can, kill one of the nodes, and you'll probably won't even see it happen. And it's just the way that we built the system where it just acts like nothing happened. And so we want to get as close to that as possible with transactions. So in
hmm,
the case, like you said, like in the middle of the transaction, it dies, the other nodes can pick it up.
okay,
And I will tell you right now, this is where our very extensive fuzz testing comes in on the project. Like the
mm,
last 6 years of our testing framework has been built around these ridiculous failure scenarios because we all rely on Cassandra to run our businesses. Apple has some great talks about this. They run hundreds of thousands of Cassandra nodes. They can't handle failure. If it fails, then you lose pictures on iCloud. So they can't handle it. I mean, if you really want to have a fun job, building test apparatuses for Cassandra is amazing because you just think of the most horrible things you can do to infrastructure and write code for it. Yeah,
interesting. That
yeah.
sounds fun.
It is fun. I've done a few myself. Yeah.
Yeah, yeah, pretty interesting. Great. So, like Cassandra is going to help developers take off all the burden from their applications, but how is the migration going to look like? Let's say I'm using the old versions of Cassandra and I have a lot of like application level logic to support these like gaming use cases, for example, and then I want to move that to
Mm-hmm.
Cassandra. Is it like, okay, I just delete all my code and then upgrade the Cassandra version and expect everything to work fine? How is the migration going to look like?
That seems like something you can just get Chat GPT to do, right? Not yet, but for your use case, where hey, I've already built this and I've built it all in code, and now I want to move to Cassandra 5. First of all, this is a non-volatile upgrade, and this is how we've always run Cassandra. You should be able to run any version of Cassandra and upgrade to the latest one, and in very few cases, it will break your code. The I think the last one we did was we finally shut down the thrift protocol. So the actual whole protocol was no longer available. So if you're writing code with thrift, then it will be gone in 5.0. So that was a big one. We haven't done that ever. That's the first time. But if you're running 4.0 and you want to go to 5, you can upgrade your cluster in place. It's an online upgrade. It should run just fine. But for developers, that just means that everything you have was working exactly the way it should. Now though, you have more functionality. So in this case, like your case you're talking about, you can't just delete your code and walk away. But I think what I would do as a developer is look at, okay, so here's the code that handles all that stuff. How can I either shrink that down into one statement in my development environment? And it would just be that, is taking that logic and putting it
Yeah.
putting it on Cassandra. So it'd be a lot less code.
Yeah, very interesting. I'm sure this, as and when people adopt like the new versions, there'll be a lot less code to maintain and test. And eventually all the bugs, and because of these race conditions and incorrect code and whatnot, is going to go away. So that's really interesting. Great. Let's talk a little bit about the latency. So in short, are we saying because the new transactions are going to just add one extra round trip, are we just saying that the latency is going to just increase by that extra round trip and that's it?
Yeah, I'll just full disclosure. We don't have exact numbers yet
Okay.
because we're doing all of the work right now to make sure it's correct. And then we'll turn the big load tests on it and start optimizing. And I expect that we'll learn quite a bit along that line. The expectation and the way that the protocol is designed is that it does do the minimum amount of hops. And that isn't too far away from what you can get with a quorum consistency level, because that
Hmm.
still has to do a round trip. And it's very likely that you can do, especially the way that the replica sets work, that you should be able to do inserts very quickly, milliseconds or less.
Hmm.
And of course, consistency levels are at your choice with Cassandra, but if you're going full consistency. And the other thing that's probably we need to understand is right now we don't put a limit on how many different state gatherings you can do, or how many statement you could put 100 statements, update statements, or insert statements inside of one transaction. These are things that we're going to have to understand so we can communicate well with developers. It's like, hey, look, if you do one statement, this is what you should expect. If you do 100,
Yeah.
it's more. And then that should be expected. How much more? It's not going to be linear because Cassandra is not
Mm.
linear. And when you do a multi-partition, it becomes a parallel operation. But yeah, this is like on top of my list, is really being able to communicate how fast you should be able to expect something and then work with that. It will be faster though. Way faster than
Yeah.
Spanner, that's for sure.
Interesting. And you mentioned there's no like recommendation so far to how many statements you can pack in your transaction. But is there a recommendation on the number of keys you're touching as part of your transaction?
That's what we're
Even
going to have
there,
to
it's
figure out. Yeah. Infamously, I was the one who put in the batch transaction limits because every time, because I was working as a consultant and I always ran into people that put in a million. And they're like, Cassandra sucks. It doesn't work. I put in a million batch transactions and it didn't work, or it slowed down. And I'm like, okay. So we, as a project that is really user driven, like people who use Cassandra, we don't only build it, we use it.
Hmm.
We will be putting the constraints in there that we need to, but we just don't understand enough. And we're not going to do, this is what we don't do. We don't put artificial limits on it because we are afraid. That's Cassandra's thing. If you look at the history of Cassandra, we've optimized on the other side of things. We just let you do whatever, and then we'll go back
Yeah.
and fix it. Test your code. Yeah.
Yeah, the testing is not going to go away, that's for sure. By the way, talking about constraints, we also talked about allow filtering clause last time, and you
Yeah.
mentioned that it's going to go away. Is
I
it
want
going
it to
away
go
with the
away.
new version?
We just can't seem to get away from allow filtering. I've been on the mailing list. I've been in every Jira I can to talk about, can we figure out a way to stop this? There's use cases where allow filtering is still important. There was actually a recent discussion on the mailing list about creating two different
Hmm.
versions. Because what allow
Okay.
filtering does, just from an implementation standpoint, is that it says, okay, I'm going to allow the coordinator to go gather tons and tons of data and filter it in memory.
Yeah.
And that's just not a very efficient operation unless you do it on a single partition. If you had a million columns in one partition, that's actually not too bad. But if you had a million partitions, that's horrible. It's just going to take
Yeah.
forever. So it's that kind of, there's a good and a bad, and it's still useful in a lot of cases. And like Spark jobs use allow filtering, and they're okay with it because it's a Spark job. It's not meant to be
Yeah.
fast. It's meant to be
Yeah.
efficient. So I have not won that one yet, but thanks for bringing it
Okay.
up.
Cool. Just to end our discussion on the asset transactions topic, I want to compare it with the lightweight transactions that Cassandra already supported. So lightweight transactions had this limit, right? Like how many number of keys you can touch. Am I right? So
Well,
how
you
does
could do a bunch of lightweight transactions,
okay.
and the
Yeah,
batch has a
okay.
limit. Yeah.
Okay, interesting. In this game, like the game example I took on like buying that sword, with lightweight transaction, what was not possible? What was the problem?
Yeah. Lightweight transactions only touch one partition at a time. So what you
Hmm.
didn't get was that exclusive operation. You could do a lightweight transaction. Like I want to change the one thing. Like I wanted to give your inventory or the player inventory. I want to change the player inventory to one Vorpal sword. You could do that
Okay.
exclusively. Or
Okay.
even decrement this check and set. You could decrement how many Vorpal swords are in the item inventory. You could do that exclusively, but only that.
Okay.
You couldn't do all of it. So here's the race condition that you would run into. This is, and I'm going to use your example of what if the user doesn't have enough coins? So you
Hmm.
minus it off of the items list. You go over to the user and say, all right, I'm going to check and see if you have enough coins. Oh, you don't. Uh-oh. I better put the sword back. So now you've got code that will reinsert the data, re-update the data to do the rollback. So that's when you need the rollback, is when
Yeah,
you're doing these things one at a time in your code.
makes sense.
Yeah, and that doesn't work. It was really lightweight transactions were really good for race conditions around a single table, single key, like changing a user profile or something like that.
Hmm.
And they are
Okay.
used at scale all the time, but
Interesting.
not for group activity.
Okay, very interesting. So finally, my gaming example is going to work with the asset transactions in the new Cassandra version.
Mhm.
Great. Let's talk about the vector searches that you mentioned. What is a vector search?
Vector search. Yeah, this is the latest hotness. You're getting exclusive information here. This is really new. We're discussing it right now. So storage attached
Okay.
indexing, which is the new indexing scheme, which will be in 5.0, is very useful for lots of reasons for developers, but it's also great for us as Cassandra developers because it's giving us the ability to do different kinds of indexing. Vector search, if you've been playing with AI or machine learning in the past 6 months, vector search has really kicked into gear because that's, for instance, ChatGPT. I'm going to use ChatGPT. It does these
Yeah.
things called embeddings, and embeddings are just like, here's a bit of text, and I want to be able to load multiple pieces. Like, how does it remember what I just said? If you're having a conversation with ChatGPT and it remembers the third thing you said ago, those are
Yeah.
embeddings, and that what so what the embeddings are in a vector search, and this is like a different kind of search engine. Search has been mostly text, like we can search for
Hmm.
a word or a letter, the character. Lucene and Elasticsearch have done that really well. But what if we have things like an image or some audio? There's a whole different problem there. Do we convert it to text? No, don't do that. So we have this multi-mode of information out there in the world that needs a better way to search for it. And we've proven that search is important. I want to know if I type in, like we Google all the time, here's my word. I want to type in Cassandra, click, and here's all the stuff that I found that has that word in it. What if I say, here's a picture of a hot dog? Show me all the other pictures in there that look just like this. That's a hard problem. Facebook did a lot of research on this, and there's a few other libraries, but it has to do with these neural networks that they understand, they learn. But then what do you do with that? Instead of having to take that picture of a hot dog and run it through a neural network and your really expensive NVIDIA A100 cards every time you do a search, they create an index, this vector index. They call it a dense index. If you look at like TensorFlow, there's this type called a dense type. And
Mhm.
it's just a small array of numbers. And if you think about it in a 3D space, they're indexing just like an index can break down text. It takes like binary data of some sort, runs it through an algorithm, and then puts it into a 3D spot. So then, okay, then what do you do with that? That's where search comes in. If I have pictures that all look very similar, they'll all wind up in a very similar 3D space. So
Mm.
then the search engine says, hey, like how close? And that's what the search does. It says, I want things that are close within some radius. And
Yeah.
it'll find a bunch of things in this 3D space that are very similar to each other. And so here's a bunch, all of a sudden you get a picture of a bunch of hot dogs. And I think it's not a very difficult thing to think about, but it's a hard thing to implement. And there are vector databases, specific vector databases out there like Milvus, Pinecone, Weaviate. That's the only thing they do is vector search.
Yeah.
But what we looked at was there's so much machine learning and AI data already in Cassandra. People are using Cassandra for feature stores and things like that.
Mm.
It just seemed like the logical thing to add very simply vector search inside Cassandra. And then we used storage attached indexing to it basically make that a really easy operation to do. So we'll use create index on, and then you can index your data, and it will then you can do a where do cosine search. We're going to have a whole bunch of stuff about how to use it, but essentially you're going to be able to search data inside Cassandra using vector search instead of text search. That's going to really
Mm.
change things.
Interesting.
That was a long
Yeah.
answer.
That No, I think that makes sense. And giving that, like you mentioned, there's a lot of AI and ML data already running hosted on Cassandra servers. So adding this ability to be able to search based on images, I think that makes a lot of sense. And it's going to open up a new world of use cases for Cassandra.
It also works on blocks of text too. I think it works on anything, but it just is a very different way. Like the way that like any GPT LM works with embedded data, it indexes a block of data, a block of text in a certain way. Like
Mm.
like here classic, you upload like a transcript from YouTube and you say tell me all about it, or you upload 2 blocks of transcripts into chat gpt and you say compare these 2 things. If it indexes those blocks of text in a certain way and it puts them in adjacencies, it can start using that almost like a memory, like, oh,
Mm.
that sounds familiar, oh, I saw that before. That's
Yeah.
what it can do. It's really crazy.
Talking about all these new features like vector search and mainly on asset transactions, how is the data modeling in Cassandra going to change? Is it going to change? Are you going to give like a new recommendation on how you should model your data?
Yeah, my all my data modeling talks for years are going to be completely broken. But that's okay. That's progress in technology. Storage attached indexing will change the way you can do a very rich select statements. Soon we'll be adding ors and counts and things like that that are people have never been able to do. Asset transactions will greatly simplify code, but also increase the complexity of the query, but it's a completely new query. Those are just 2 examples of things that are going to change the way we've done Cassandra data modeling.
Interesting. Cool.
Yeah.
Yeah, that's all sounds interesting. I'm really excited and looking forward to more developments and more talks on Cassandra about the new features, and also looking forward to try them out. And it was really insightful talking to you and great use cases that are going to open up for the Cassandra community, and with all these new features. So yeah, great
Yeah,
development.
you're
And
you're definitely a helping hand for those of us out there who love the deep knowledge. So I appreciate what you do. And yeah, I hope to see you at the Cassandra Summit. We're doing that in December. I'll be talking about all that stuff. I know it's long ways out, but we will have a lot of folks there talking about Cassandra 5 and probably what's going to be happening in 6 and machine learning. And yeah, so shameless plug for the Cassandra Summit, cassandrasummit.org. Come and hang out
awesome,
with our
awesome.
community.
Yeah, absolutely. Would love to.
Yeah, I'd love to
Great.
see
Thanks a
you
lot,
there.
Patrick.
We could do this live.
Yeah. Yeah, it would be awesome. Yeah, makes
Yeah.
sense. Great. So thanks a lot, Patrick, for joining me today and sharing all the insights. I'm really excited and looking forward to another collaboration on some other new feature.
Great. Thanks for having me again.